The closest star to us, the Sun, appears to be the largest body in the solar system, as it rises and sets every day. And although it dwarfs most things that come close to it, in reality, would you believe that the Sun is just an average-sized star? So the question comes here: how big can stars theoretically grow? Before we give you an answer to that, let's introduce you to some giants. The universe boasts far larger stars that aren't just a little bit bigger, they are stunningly bigger. So how big is the largest star we have observed so far? Before we look at the largest by sheer physical size, let's look at the current largest by mass, named BAT 9998. This star is an estimated 226 times the mass of the Sun. That's 226 suns worth of matter, all crammed into one. How this star became so massive isn't fully understood, but it may be the result of two stars that once merged together. Scientific models suggest that BAT 9998 is only 7.5 million years old, making it extremely young when you think of the age of the Sun at 4.6 billion years old. And that it is also shedding its mass at a rapid rate. Since its birth, models suggest it has lost 20 suns worth of mass already. Because of how active it is thought that it will inevitably end its life in a catastrophic way, most likely a supernova that leaves behind a black hole. But although BAT 9998 is extremely massive, it is nowhere near the largest by physical size, with an estimated radius of 37.5 times that of the Sun. It doesn't even come close. If you search Google, "What is the largest star in the universe?" you will receive pages of websites telling you it is G64, a red supergiant that just a few years ago was considered the largest star by physical size ever observed. It was originally measured to be around 1,700 times the size of the Sun. Can you imagine its size? However, it turns out that the distance of G64 from Earth had been measured incorrectly, significantly altering its estimated radius to 775 times the size of the Sun. This new measurement actually puts G64 closer in size to popular stars like Antares, still unbelievably enormous, but nowhere near the largest. In fact, it currently doesn't even make it into the top 80. So what about another star that was also believed to be the largest just a couple of years ago, named Stephenson 218, a possible red hypergiant star that was estimated to be so big that if it was placed in our solar system, it would engulf the orbit of Saturn. And if you could travel around it at the speed of light, it would take almost 9 hours to complete one loop. In comparison, making the same trip around the Sun would take only 14.5 seconds. Some estimates put Stephenson 218 at being 2150 times the radius of the Sun. But according to the stellar evolutionary theory, that might be problematic because there could also be a theoretical limit to how big stars can apparently grow. When it comes to the largest stars in the known universe, it depends on whether we are talking about mass or total volume. Mass can be thought of as how much mass matter a star contains, whereas volume is how much space it takes up. The most massive stars tend to be quite unremarkable when it comes to sheer size, and the most voluminous stars often contain a lot less matter considering their physical size. As stars get older, they tend to lose their mass. This is something that is happening to the Sun as it grows in age until eventually, in an estimated 5 billion years from now, after it has exhausted all of its nuclear fuel, it will evolve into a bloated red giant, engulfing the orbits of Mercury, Venus, and possibly even Earth. And although this process will make our Sun enormous, there are stars out there that come a lot bigger. Observe galaxies with powerful telescopes and billions more things are revealed. In fact, the Milky Way galaxy alone is estimated to have between 100 to 400 billion stars, and look even further to our neighboring galaxies and beyond, and there are an unaccountable amount more. Well, according to the list of largest stars known, that title is currently held by a red supergiant called WOH G64, a star located around 160,000 light-years away in a neighboring satellite galaxy called the Large Magellanic Cloud. As mentioned earlier in this video, according to the theory, the limit a star can grow is around 1,500 times the radius of the Sun. This could mean that Stephenson 2.18 has been overestimated, possibly due to its distance from Earth being uncertain by as much as 50%, which, like WOH Scuti, would significantly alter its estimated size. But then again, as far as I could find, there is no clear-cut equation that determines how big a star can grow, since it depends not only on mass, but composition, evolutionary history, and the strength of its stellar wind. So based on our best measurements, what is the current largest star in the known universe? WOH G64 has an estimated radius of 1,540 times that of the Sun, meaning that if it took the place of the Sun in the solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. This measured radius also fits in nicely with that theoretical growth limit and is consistent with many other large red supergiants found elsewhere. WOH G64 is likely in the latter stages of its stellar evolution. These types of stars have exhausted their nuclear fuel, leading to the expansion of their outer layers, transforming them into true cosmic giants. The enormous star is also shrouded in a torus-shaped cloud of dust about a lighter in diameter, which consists of material it has expelled. Incredibly, it is estimated that if all the material in the Taurus cloud was collected, it would be enough to make our entire solar system 9 times over. So have we finally cracked it? Is the WOH G64 the largest star in the known universe? Probably not, because there have been other studies that have also measured this and got a completely different measurement, although one source did put it at 2,575 times the radius of the Sun, making it far bigger than even Stephenson 2.18's possibly overestimated size. If this is correct, then it would easily engulf Saturn's orbit, and if you could once again travel around it at the speed of light, it would take almost 10.5 hours to complete one loop. In comparison, light from the Sun travels to Pluto in only 4 hours. So although it is clear that the universe is full of some truly enormous stars at different stages in their evolution, until we can gather more accurate measurements, which one is the overall largest isn't clear. However, with ongoing advancements in observational techniques and technology, astronomers will be able to refine their measurements and so understand these details far better. WOH G64 could well be the largest star ever observed in the known universe. What are your thoughts on this? Write down in the comments section. Subscribe to Space Centric Archives for upcoming educational videos related to space science. And press the bell icon. Thank you for watching this video until the end.